the question, we will stop and discuss the general principles involved in the question. Here we go. So there is this famous thing, there is this thing I am auctioning, okay? I won't tell you what it is. Here, I am auctioning something, I have hidden it under my jacket. I am auctioning this. So if I don't tell you what I am auctioning, do you know the valuation of the thing that I am auctioning? Do you know your valuation? You don't know. Clearly you don't know. And I am telling you that I will only let you see what I am auctioning after you have decided whether you want to be a part of the auction or not. To be a part of the auction, you must pay me an entry fee. If you pay the entry fee, I will show you what I am auctioning. Then you can pay. But to see the good, you must already be a part of the auction by paying the entry fee. That's the essential point. Yeah? So the entry fee, I am told, is $2.50. You won't see the good until you have paid this entry fee. Once you see the good, you will become aware of how much you value. But regardless of the fact that you don't know your valuation before you pay the entry fee, you know that this is a good such that everyone's valuation of it is drawn uniformly between 0 and 15. I know this much. This is common knowledge. The population of bidders, the valuations they come from, that's common knowledge. You know it always, okay, even before you see the good. The auction will be a first price sealed bid auction, that's told to me. And I am asked the question whether I will participate in this auction. Notice the difference first. Generally, the questions we have looked at so far, we have been deriving equilibrium bidding strategies. What is a bidder strategy in equilibrium? Here the question is not asking you what is a bidder strategy in equilibrium. The question is asking you, will you participate in this auction or not? Will you pay this entry fee or not? That's the question. That's what the question is asking. Will you pay this entry fee given that it is a first price sales bid auction and you know there is one other bidder who has already paid the entry fee? One other bidder is participating. You know this. Okay, you know this. Will you participate in the auction or not? This is where you see how the different tools that you learn in the course come together. For example, how do I even approach the question? How do I even? Will I participate in the auction or not? Think. I am being asked whether I will participate or not participate. What sort of a problem is this? It is a lecture 1 problem, decision problem, where my choices are between 2 options: participate or not participate. Participate or not participate. So if you want to make this problem clearer in your head, you can start by drawing your decision tree. Really speaking, I am being asked whether I will participate or not participate. That's it. And what will I base this decision on? I will participate. If I participate, what can happen to me? What can happen to me if I participate? Or, that's it, yes. So can you guarantee me that I will win if I participate? Therefore, what node will I hit here? Exactly. And there are 2 outcomes. Either I might win or I might lose. If I don't participate, what will my payoff be? 0. Okay. So I know that if I don't participate, my payoff will be 0. Our bidder is risk neutral. All I need to do is to calculate the expected value at this probability node, compare this to this, determine which one is higher. Simple. Okay? Clear? So once I determine that this is what I am going to do, I have identified the structure of the solution. Now all I need to do is to do a little menial work. Fill in all the values, ask myself what the probabilities are going to be. After that it's clear. But the structure is important. I have got, this is what I am trying to do. Alright. So probability of winning and losing I will come to in a bit. Let me see what happens to my payoff if I win or lose. Losing first. If I lose the auction, what will my payoff be? 0. I don't win the good. I don't have to pay any money. But unfortunately, I have to pay the entry fee. This is important. Must remember this. Okay, so my payoff from losing the auction will be 0 minus 2.50. Okay. What will be my payoff from winning the auction? You already know, even if I win, there will be a minus 2.50 here. I will have to have paid the entry fee. If I win the auction, a very simple usage. If I win the auction, this is a first price auction, whatever I bid I must pay. My valuation, if it is V1, the payoff from winning will be V1 minus V1. Right? Okay. Now, I am deciding whether I should participate or not, whether I should pay the fee or not, which means I haven't even seen the good, which means I don't even know my valuation. Therefore, I don't even know how much I should bid. How am I going to determine V1 minus V1? I don't know it. How am I going to determine? I will ask myself the question, okay, if I knew my valuation, there is one other bidder, I know how to calculate how much I should bid, then I will do V1 minus V1, I can find if I knew my valuation. But if I don't know my valuation, I can only ask myself this question, okay, on average, the guy who wins such an auction, everyone's valuation is drawn from here. On average, the guy who will win this auction, what will his valuation be? That's the question. If I knew my valuation, I will use my valuation. But if I don't know my valuation and I am wondering what will be my payoff from winning, I am asking myself the question, if I win the auction, so well, it must be because I bid the highest. If I bid the highest, it must be because my valuation was the highest. But I don't know my valuation. Therefore, I am looking for the valuation on average of the guy who will win the auction. The highest valuation on average. On average, what is the highest value? That's what I'm doing. Okay. The guy who will win the auction must be the guy with the highest valuation. I don't know what valuation is that. So I am asking myself the question, on average, what is the highest valuation? Clear? If I don't know my valuation, general principle number one, if I don't know my valuation and I am thinking about what will happen if I win, I assume that my valuation is the highest valuation on average. That's what I assume. In other words, this is 0 to 15. There are two bidders here. Two bidders. I know that I am thinking about participating. If I participating, there is one other bidder. There will be two bidders. I am going to place them, divide this into three parts and place one bidder here. I am here. If I win, I am here. On average, I am here. If I win. That's the idea. This is 5, this is 10. Therefore, on average, the valuation of the guy who will win the auction is 10. That's the expected highest valuation. If you wanted, you could have used formula number 4. But I don't need to use it because this is starting from 0. Okay, in here. Okay. Now, so on average, the guy who will win the auction, his valuation is 10. So I am assuming I am winning the auction. So on average, my valuation is 10. How much should I bid? This is the first price auction. I should assume that I am the highest valuation, bid the next highest valuation. What is the next highest valuation? Assuming this is the highest? 5. Therefore, on average, my valuation will be 10. On average, how much will I bid? On average, what will be my surplus from winning the auction? 10 minus 5. Here, this is very important. If you know your valuation, you calculate V1 minus V1. That's your payoff from winning. If you don't know your valuation, you find on average what is your payoff from winning. That is your average valuation. If you win, average highest valuation minus how much ever you will bid. Okay. So you get 10 minus 5 here. This is average valuation, highest valuation, minus 5 minus 2.5. So 5 minus 2.5, 2.5. Okay, if I win the auction, on average I'll make 2.5. If I lose the auction, I'll make minus 2.5. Okay, all I need to do is to ask myself, what is the probability of winning and losing? Okay, what is the probability? This is the payoff I will get if my valuation is the highest, if I win the auction. But is it guaranteed that my valuation is the highest? If my valuation is the highest, this is what I will make. But there is no guarantee that my valuation is the highest. The other fellow's valuation could be the highest. All I know is that the guy who will win the auction will have the highest valuation. Okay. So what is the probability? I don't know my valuation. I don't know the other guy's valuation. I don't know how much I'll bid. I don't know what the other guy will bid. What is the probability that I'll win the auction? Has to be half. Has to be half. Has to be half. I don't know if it doesn't make sense to you. I'll ask you this question. I tell you team A and team B are playing a football match. One of them must win. I tell you nothing about who team A is or team B is. Ask you what is the probability that team A will win. What must you say? You know nothing about your valuation, the other guy's valuation, you know nothing. Okay? So the asymmetry in information, complete lack of information here. Right? Your ignorance is symmetric. You know nothing about yourself, you know nothing about the other bidder, his valuation. Therefore the probability you will win is half. In general principle number 3. If you guys don't know your valuation and you are participating in an auction with n other bidders, the probability that you will win, the probability that your valuation is the highest is 1 over n. Okay? In general, with n bidders, when valuations of the bidders are not known, the probability that a particular bidder will win is 1 over n. 1 over n. Okay? 1 over n. Right. So half and half, all the values are in. All you need to do is to calculate the expected payoff at this probability. Half times 2.5 plus half times minus 2.5, which gives you. So the expected payoff to you from participating in the auction is 0. The payoff to you from not participating in the auction is 0. What should you do? You should be different. Remember, under our assumption is bidders are risk neutral, okay? Unless explicitly stated, bidders are risk neutral. That is why I compare payoffs with payoffs. Okay? Bidders are risk neutral, unless I state it explicitly. And if bidders were risk averse here, what should you do? If you were a risk averse bidder, not participate, clearly. 2 options, one is a lottery, one is a certain amount, the expected values are the same. A risk averse bidder will choose the option that is not lost. Don't worry. Okay. Alright, done. Let's quickly look at what happens when there are 3 bidders in play. 3 bidders. That means you are asked the same question, you are being asked the same question, but now you are told that there are 2 other bidders participating. 2 other bidders. The question is still the same. Do you participate or do you not participate? 0, 15. Okay? Alright. The decision problem is the same. If I don't participate, I'll get 0. If I participate, again 2 things will happen. Either I might win or I might lose. If I lose, I'll get 0 minus 2.50, no problem. If I win, again the same problem. I don't know my valuation, therefore I'll ask myself, on average, the guy who wins, what is his valuation? On average, the guy who wins, what is his valuation? The guy who wins, on average, has the highest valuation. Now there are 3 bidders. Therefore, I'll divide this line segment into 4 parts. And this is the, on average, the guy who wins has this valuation. Okay. Now what is this? 4 parts, 15 over 4 is 3.75. This is 3.75, 7.5, 10, 11.25. On average, the guy who will win has this value. So if I'm assuming that I will win, it must be that on average I'll have this value. And if I have this valuation, how much will I bid? I will assume my valuation is the highest, bid the next one. Next, which is 7.5. This will be my bid. Therefore, the payoff I will get from winning is 11.25 minus 7.5, which is 3.75. So here I have 3.75 now, minus the entry fee 2.50, which is 1.25. If I lose the option, I have minus 2.5. Therefore, the expected payoff now, probability of winning, guys, 3 other bidders, 3 bidders, 1 over 3. I don't know anything about my valuation or anyone else's valuation. The probability that I have the highest valuation probability that I will win is 1 over 3. So this value is now 1 over 3, this value is now 2 over 3. Therefore, the answer, the expected payoff here now with 3 bidders is 1/3 1.25 plus 2/3 minus 2.5. And clearly it's less than 0. This is a bigger number, absolute terms, bigger number. The negative number is a bigger absolute number, the probability is higher. This is a number that is, you can check, less than 0. Less than 0. Therefore, with risk neutral bidders who make their decisions based on expected values, in this case, I will not fund. Clearly not fund. With 3 bidders, I will fund. Questions, guys?